Hi. Hi, how are you?
Good, Professor.
Good,
How is everything?
good.
Happy. How
Yes.
many people we are? 34? We wait a few minutes more to have more people.
While we are, I was going to ask you about the test you get a chance to take. Because,
Betsy, at the end,
yeah.
at the end of the class, you remind me, okay?
Okay, I will. Thank you very much.
Professor, were you gonna reopen the quiz for those questions that were marked wrong, but they were right?
No. At the end of the course, you let me know what are wrong and I will review it. Because I think that I don't understand very clear. Is that you put 56 meters and is correct, but it didn't give you the...
It's because of the type. It's
Screenshot. I put 54 meters over second, but he marked it wrong because the right answer was 54 space meter over second.
Yeah, I understand. You remind me at the end of the, because I don't know how to correct these things on Canvas. So you remind me at the end of the course and I will add the points that you deserve, okay?
That same thing happened to me. I put meters, like I spelt it out, and it said that it was only the M.
Yes.
So it counted it as wrong.
You let me know. You tell to Tatiana, he will write down everything and she will remember everything before
Okay, I took a picture of it just in case.
Before the course end, she will remind me everything, okay?
Okay, thank you.
I'm trying to use a new system to teach you. Let's go to see if it's going to work, okay? Let me see. It's the first time that I use it like this. I hope I will. Let me give me 1 minute to, because it's new system for me. I will explain you what it does. So maybe this system is okay. How many people we are now? 50, 60. Okay. Let me add something here so we can start. Let me add something here. Well, I think I'm okay. Let me see. I think I'm okay. I'm okay now. Let me take out just a moment. 1 minute, please. 1 minute. I'm done. Okay, now let me share my screen, and let's go to see if you like this way better. Okay, is everything, everybody can see my screen? Okay, good.
Professor, at the end of class, can you go over some of the stuff that was on the quiz?
Yes, yes,
Thank
if you remind me, what do you mean? Some question that you didn't know how to solve?
Yeah, some of them we had trouble solving.
Yes, we can do it.
Thank you.
But you have to stop me because I don't see the time, and sometimes, you know, it's one, let's go to do it like this, it's 1:42. At 2:30, we are going to have a rest. We are going to rest for 5 minutes, 10 minutes. So at 1:30 we stop, 1:40 we start again. And at 2 p.m. you stop me and we start to see the quiz. Okay?
You mean at 3 p.m.?
Sorry, at 3 p.m. Right, at 3 p.m. 3 p.m. you stop me and we start to see the quiz. So this is the way that I'm maybe trying. You let me know if this way is more comfortable for you, easier to do. So what I did is on the Father's Day, I show you my daughter gave me this gift. It's a notebook. It's called Wave. The advantage of the notebook is that you write on the notebook with a special pen. You can erase anything on the notebook. Anything that you write, you can erase. So the advantage is that you can synchronize every page with Dropbox, for example. So you can send a scan of every page to Dropbox. From Dropbox, I import to explain everything to this program, and I have import all the page that I have wrote. Is the second page, etc. I have to see if the order of the page are correct. I hope so. I don't think that is correct, but we will see how to do it. Okay, we will see. So the idea, my idea is, I will explain here the class, and I will upload I will upload to YouTube or to Canvas what I explain, and I'll try to make it easier for you to review the class, okay? So I can separate the class in parts, we can say. So let's go to start. So what we have seen for the moment. What we have seen for the moment is Newton's law. We have seen the first law. This is the first page. Yes, the first page. The first law say that if the sum of all the forces are zero, means that the acceleration is zero, means that the velocity is constant. Constants mean that can be 0 all the time or can be constant, 5 meters per second all the time. So this means that the quantity m by b, if b is constant, well, p is constant. So the velocity is simple, a vector that is the vector p divided by m. You can see from here. So the first law says, if the force is 0, the acceleration is 0, and the expected velocity is constant, so the velocity will not change in direction and will not change in magnitude. The magnitude will be fixed. The other point of view is if the sum of forces, the other point of view is to say like this, if the sum of the forces is 0, the acceleration is 0, b is constant, and p is constant. So the other way to say is that there is no force means that p is constant. So there are two identical ways to express the same thing. This way express the quantity mb, and this way express only the velocity v. So this way say that p, the vector p, the vector mb cannot change in direction, cannot change in magnitude. The second Newton's law say that in case that the sum of all the forces is 0, how we can calculate the force? We can calculate the force using this equation. That the sum of all the force, what it will do, it will create acceleration. And the sum of all the force will be the mass by the acceleration. So the mass will be m, the acceleration will be final velocity minus initial velocity. This is the acceleration. Divided by delta t, so will be mb1 final minus mb1 initial. Is correct? Is correct or not?
Yes.
Yes.
Okay, let me see if I can. No, I cannot move this. So what it say, the second way to see the Newton's law is to say, what is this quantity?
Professor, could you please mute everyone?
Sorry?
Could you please mute everyone?
Oh, yes.
Are you looking at me?
Just a moment. Let me mute everybody. Let me see. Sorry. Now, okay. Now is everybody's
Thank you.
mute. Okay, so the other way to see to write the equation, one way to write the equation is to write that the force or the sum of all the force is the mass by the acceleration, and the other way to write the Newton's law, the second Newton's law, if you see here is P final. If you see here is P initial. So the other way to write the equation is that the sum of all the forces is the change in the vector momentum, P final minus P initial per unit of time. So P final minus P initial divided by delta. So this is the other way to say the same thing. This is equivalent to this. It's the same thing, only that when you use this interpretation, you follow the momentum. You follow the momentum. If the momentum P, which is MB, change, let's say that this is P1, it changed to P2, well, there is a change in the momentum. This is the change, delta P, P2 minus P1. So this is the force. The force is the change per unit of time. Here is the force. Okay? is the same interpretation that this one. If V1 is like this, and the final velocity is like this, the change in the vector velocity is this one. This is the change in the vector velocity. So the force is the mass by the change in the velocity per unit of time. This is the force. So this interpretation is more powerful than this interpretation. So implication. The first implication is that we define an inertial frame as the frame that covers the first law, meaning that if there is no force, the vector velocity will not change. And at this kind of a system of reference, that the direction of the object will not change when there is no force, we call it, how we call it? How we call this kind of frame?
Inertial frame?
Inertial frame. So the first law defines an inertial frame as the system where an object that is where it's not acting any force will move with constant velocity, meaning that the velocity will not change in magnitude, will not change in direction. So let's go to the next law. The next law is the second law, that it says that this force, the mass by the acceleration, is the same as this. This is the mass by the acceleration.
Professor, could you go back to the first law for a second, just so I can take a screenshot?
If I go back to where, sorry?
The first law for a second?
Yes. Yes, but you will have this, and I will pause everything here.
Oh, okay, okay. Thank you.
Okay?
Thank you, thank you.
Professor, before you leave the screen, I have a quick question.
Yes?
So this page is for the first law,
Yes.
and it says if the sum of forces equals 0, R equals 0, V is constant, and the magnitude is constant
The first law is here.
at the
The
top.
first law.
It's A equals 0, not R equals 0. And
A-
these are all three. These are all three laws, not just the first one.
That's A? Oh, that's
A.
an A. Okay, never mind. Thank you.
The acceleration is 0. If the acceleration is 0, it's because the velocity is constant. Because there is no change in velocity, because the acceleration is the change in velocity. If the velocity is constant, the momentum is constant. So the first law says that if there is no force, the momentum will be constant. So I can write.
Thank you, Professor.
Sorry?
Thank you. That makes sense.
Okay. If the first law says if there is no force, P, the momentum, the quantity P by MB will be constant. And why it will be constant? Because V will be constant. So the vector MB will not change if there is no force acting on the body. Okay? The second law says that the sum of all the forces is the mass by the acceleration. And if you see that the acceleration is V final minus V initial, and you make this distributive property here, will be m by b1 final minus m by b1 initial. But this m by b1 final is p final, the final momentum and the initial momentum. So the force is p final minus p initial. So it's delta p divided by delta t. Can I go to the other page? Yes, no?
Professor, did you skip over the third law? Or did you go over that
Oh,
third part?
The third law, the third law say that if you have one particle moving here with some momentum of some velocity V1, and V2, and there is interaction between them. This is the interaction. Maybe repulsive. In this case, it's a repulsive interaction because as you can see, one is going farther than the other one. So the interaction is repulsive.
In a problem, how do we know that they're interacting?
They are always interacting. Always two particles are in two states. Either they don't recognize the other particle, so means that they are not interacting, or they are interacting. If they are not interacting, it's because they live in a universe where they are lonely, very alone, very far from any other thing. So it's an idealization. Non-interaction is something that is an idealization. You cannot exist with no interaction. This is the real thing. This is an idealization in the case that there is no interaction. But in the case that there is no interaction means that we don't exist. So it's something hypothetical, something that say, suppose the interaction is so low, so low, so low, that we can depreciate the interaction done to the body. So if the body is moving with constant velocity, he will move again in a future time with constant velocity. But if there is no interaction, means that there is no one to see this. So how we will prove this? If we see it, we are interacting. So we cannot prove it. We are supposing that this will happen. You catch this idea as an abstraction.
Yeah.
An abstraction that say, suppose that you are on the surface on an ice, on an ice surface, and there is nothing interacting you. You will not move respect to the surface, or if you are moving respect to the surface, you will maintain the movement respect to the surface forever, because there is nothing stopping you. And there is nothing accelerating you. There is no force. So it's an abstraction of what it will happen. So it says that if you see, for example, in the universe, a particle moving, but if you see it, you are interacting with them, with the particle. But suppose that the interaction when you see is so minimum that the particle is not noticeable, the interaction. It's so weak, the interaction, that the particle does not notice that you have seen the particle. So in this case, what it says that the particle in the universe will move with the same direction, with the same constant velocity, and it will be a rectilinear line. This is what the first law that it says that is an abstraction, that really you cannot prove it. It's impossible to prove it, because to prove it, you have to interact. And once that you interact, you change things. But you can prove, you can imagine that this is going to happen because you make experiment with very weak interaction, interacting with the object in a very weak form. And you see that the velocity, the momentum, the vector velocity, the vector momentum doesn't change. So you make an abstraction and you say in an idealistic case that there is no interaction, the behavior of this particle will be in a way that will never change the vector velocity and will never change the momentum. And now the second question, answer, well, if it's an interaction, what happened? Well, if there is an interaction, the vector velocity will change. And how will change? How we will measure the change? Well, there is a force. So if the velocity change, it's because there is a force. And the velocity can change in two ways. Can change, V can change, increasing the velocity. So it's a change that is tangential to the direction of the velocity. Or V can change, changing the direction. Or V can change doing both things, changing the direction and changing the magnitude. So you start like this, you start like this, and you end it like this. You change the magnitude of V. The initial magnitude was this one. And now you change the magnitude in the way that you also change the magnitude. It will be very big. And also you rotate the vector. So the change is here. This is delta V. So the force is here. The force has changed the vector velocity. So what it says this equation is that the sum of all the forces will create an acceleration. The acceleration is in this line, in the line of delta V. So the sum of all the forces is the mass by the acceleration. The acceleration is V final minus V initial divided by delta T. So the force will be P final minus P initial, or delta P, the change in momentum, divided by delta T. So on the first case is the action, the third law is the action and reaction. That is, say, if the force acting on one due to two has to be the same force acting on two due to one, but with the minus sign. So this means that if the force acting on two is like this, due to one, the force acting on one due to two is like this, is the same force in the opposite direction. You see, if this is the point one, this is the point two. If the force on two due to one makes like this, the force on one due to two make like this opposite. But in the case that the force of one, the force on two due to one make like this, F2 due to one, the force on one will do in the opposite direction, F1 due to two. So this is the equation that we are studying. This is the principle of action and reaction. Okay? Okay, can I go to more pages?
Yes,
Yes?
Professor.
Yes.
Okay, so this is what I have said once and again, the same thing. So if you know F, you know the acceleration, is correct? If you know the force, you know the acceleration, because the acceleration will be the force divided by the mass. So knowing the force, meaning knowing the acceleration. Correct?
Yes.
Knowing the acceleration is knowing the change in velocity. So knowing the acceleration means that you know what is the final vector, that is the initial vector plus the acceleration by delta t. So knowing the force means knowing the acceleration. Knowing the acceleration means knowing the vector velocity. And knowing the vector velocity means knowing the position, because V is delta R divided by delta T. So R final is equal R initial plus V by delta T. What it means that the power of this is the following one. When you know the force, you will know how the particle will move, what will be the speed, what will be the vector velocity, and what will be the position at any time. And this is so powerful method to analyze object systems and knowing where they will be in future times, with what velocity they will be. That is the most important thing that you have to know about a system. To analyze a system, you need to know where the part of the system will be and with which velocity they will be moving. And this Newton's law provides you the theoretical basics to know that. So we will do a lot of examples. So I'm going to be a little bit a little bit fast because otherwise I will not arrive to the example. Okay, so a force is always have two components, parallel and perpendicular. What it means that this force, if you take a system of reference, the X and the Y, or let's say like this, if you have the velocity V and you have the force like this, F, you can make the force, you can erase this force and put two forces that the sum will be the same as this force. I consider these two forces. So this is my initial force. This is F perpendicular and this is F parallel. I repeat again. You have the force F. You have the object with certain velocity V. You have the force F. Let's say like this. Let's say, let's put it like this. Okay, this is the force. Always the force you have to visualize like this. You take the perpendicular to V. You make the projection of F. This is F perpendicular. And this is the F parallel. It is true that this vector plus this vector is this vector. It is true that this vector plus this vector is this vector. Yes, of course, we have seen many times. So it's better to visualize the force in two forces, one parallel to V and one perpendicular to V. But why is important this? Because the force that is parallel to V will make V change in magnitude. So V will increase in magnitude. And the force that is perpendicular to V will rotate the vector V. So analyzing these two forces, we can see what is the trajectory of the body when the force is acting. So in any problems, you can try to see F parallel to the velocity and S perpendicular. So the F parallel will change the magnitude of B and F perpendicular will change the direction of B. Okay, and I don't know why. Okay, let's go to the next page. To the next page is, well, no, it's the same thing. So let's go to applications, okay? Let's go to apply Newton's law. Let me apply Newton's law here, for example. Suppose, let's go to apply Newton's law. How to apply Newton's law? This is the steps that you must follow every time that you apply Newton's law. First step, you isolate the body. You know that this, it doesn't allow me, let me see if I can. Oh, now I can move it. Okay, now I am happy. Now, okay. So the steps are like this. You isolate the body, first things that you have to do. You choose the, so one prime. Choose the positive direction as the direction of the vector A, the acceleration, okay? We are going to follow this step for solving the next 10 problems, okay? So pay attention to these steps and I'm following every step. Isolate the body. Choose the direction positive as X. Draw all the forces acting on the body. Choose your system of reference. Well, your system of reference is already chosen because you choose the positive direction as the A. Third, see the components of the force, the component X and the component Y. and apply Newton's law. Newton's law says that the sum of all the force through the x-axis is the mass by the acceleration in the x-axis. And the sum of all the forces in the y-axis is the mass by the acceleration in the y-axis. Why? Why? Because the force is mass by the acceleration. And the force is something in the I direction plus something in the J direction. And the mass is mass AX in the I direction is a vector. So the vector has components in the X direction and has component in the J direction. So this should be equal to this. And this should be equal to this. So Fx equal MAX and Fy equal MAY. So these are the two equations that you are going to apply always to apply Newton's law. So let's go to apply these equations to different problems, okay? So these are the two equations that you have to apply. And to apply this equation, the first thing that you have to do is to isolate body. And the second thing is to draw all the forces that are acting on the body. You are following me?
Yes. Yes.
Okay. Okay. So let's go to see some example. So let's go to find this equation, to solve this equation. So suppose that you have a body here, and the body has some, so this is my body. So I wonder, first, isolate the body. This is my body. So the problem says like this: find the tension T1, T2 in equilibrium. What does it mean, equilibrium? Equilibrium means that the acceleration is zero. Equilibrium means that there is no change in velocity. Equilibrium means that the object is moving or not moving.
Moving constantly.
Exactly. Equilibrium means that the velocity does not change because the acceleration is zero. But the fact that the velocity doesn't change, it doesn't mean that the velocity is zero. It means that the velocity doesn't change. That if the velocity is 5 meters per second, the velocity will be 5 meters per second for future times. So the acceleration is zero, means that the velocity is constant. And in this case, the velocity respect to the observer that is here, the velocity is zero, okay, in this case. So we isolate the body. This is the body of mass m. They give us the mass m. They give you these angles, theta 1 and theta 2, okay? Theta 1 and theta 2, they give us these two angles, okay? And they ask, what is the tension T2 and what is the tension T1 that is here? Are the tension T2 and T1 applied to the object?
No.
Yes.
Yes or no?
I think yes, because they're both at an angle, no? In order
No.
to maintain.
This tension T1 and T2, they are applied to this point. The tension that is applied to the mass M is this tension.
Wait, can you repeat the first part again? Sorry.
Yes. What I say that the tension that is applied T2 and T1 is applied to this common point. It's not applied to the body. And the tension that is applied to the body is the force that the rope is making to the body of mass M. And the force that the rope is making to the mass M is T3 and is going up. So through the object of mass M, there are two forces. One is T3, that is the force that the rope is making on the body of mass M. And what is the other force?
T1 and T2?
The one going down, pulling it
T1
down.
and T2 is not acting on the mass M. The one force that is acting on the mass M is only T3, but there is one more force. It's only
The gravity?
the
Yeah, gravity.
gravity, N by G. N by G. So we will choose a direction. In this way, we can make the direction like positive going down, going up. So we will put all the forces that going up, positive. All the forces that going down, negative. Okay, so we'll write this equation. What is the sum of all the forces on the y-axis? This should be the mass by the acceleration. What is the sum of all the forces? I know that there is plus T3 going up, and I put it plus because I said that this is the positive direction of the forces. And going down is minus mg. And this should be equal m by ay. But in this case, that is equilibrium, the acceleration in the y direction is 0 because the object is not increasing the velocity up, it's not decreasing the velocity down, it's not moving. So the velocity is 0, not because the acceleration is 0, not because the velocity is 0. It's because the velocity is 0 always. So the change in velocity is 0. Okay? So the mass by the acceleration will be 0. From this equation, we have that T3 is equal mg. So what it says exactly that whatever is going down is going up. So T3 is mg. But this is not giving me the answer to the problem. The answer to the problem is the question is answer what is T1 and T2. I might know what is T3, but I want to know what is T1 and T2. How I will do? Well, I will follow this step. Isolate the body. Which one will be the body here? Well, the body is this point, and this point is acting 3 forces on this point. The first forces that is acting is T2. The second force that is acting is T1 on the point. And there is a third force. Can anyone tell me?
Is it the weight of the...
T3 equals mg.
No.
Is it gravity?
Look at this. Think about this. T3 is the force that the rope is doing on the body of mass m. Is correct?
Yes?
So applying action and reaction, T3 must be here. Is the force that if T3 is the force that the rope is doing on the body, minus T3 is the force that the body is doing on the point. You catch it? Principle of action and reaction.
So it's minus T3?
Is minus T3, yes, of course, but has the magnitude of T3 going.
The reason would be, would it be because T1 and T2 are holding up the body, but then T3 is bringing it down?
Yes. What happened?
Okay.
It will be what?
No, I'm saying, is that the reason that T3 is negative? Because T1 and T2 are holding it up, and then T3 is bringing it down?
Well, this is your observation according to your experience, to your physical experience. But the observation that I'm doing is according to the third law. Let's go to do it again. Let's go to do it in a new page. Let's go to do it. Okay, this is the body. I'm going to, this is the body. Do you agree that there is force going up that hold the object because there is a force going down? Do you agree with this?
Yes.
Yeah.
Yes. Do you agree that the equation will be T3 minus mg equals 0? Because mass by acceleration is 0, not because the mass is 0, it's because the acceleration is 0. Do you agree that now I know that T3 is mg? Yes?
Wait, Professor, we know the acceleration is 0 because the sum of the forces is 0, right?
No.
No, because it's at
exactly,
equilibrium.
not exactly because the sum of the forces is 0. It's because here there is an observer. And the observer see that the position of the object doesn't change. So, because the object, he see it in equilibrium. So he say, if the position doesn't change, the velocity is 0. So he say, okay, if the velocity never change, the change in velocity will be 0 minus 0, final minus initial. But 0 minus 0 is 0. But the change in velocity divided by the change of time is the acceleration. But if this is 0, the acceleration will be 0. So the observer will see this object that they are acting two forces and the object is not moving. It's not going up. It's not going down. The position never changed. So he will say the acceleration is 0 because if the object is not moving, it's not changing the vector velocity. So the acceleration will be 0. So I will put the 0 here and I will obtain this equation. So is this equation clear?
Yes. I also wanted to ask if this is the third law.
Wait. The third law is here. This force, T3, someone did it. Someone did this force. Who did this force going up? The rope. So let's go to make a picture of the rope. This is the rope. Okay? So the rope is not moving. This is the rope. This is the rope. Here is the other two tensions, T1 and T2, okay? This is the rope. So this T3 is the force that the rope is doing on the body. So must have another T3 that the body is doing on the rope and should go down. So this is the rope. Acting on the rope, there is a force going down. That is T3. Why? Because the principle of action and reaction say, if the body 2 is making on the body 1 a force that is going here, the body 1 will make a force on the object 2 going down. So this is the principle of action and reaction. So now I put my rope, very, very small rope, okay? Allow me to put it like a point. So I will say on the point, there is T3 here, there is T1 here with an angle, theta 1, or alpha, let's say alpha, and there is T2 here with an angle beta, okay? I think what's 30 and 60. And I need to solve now Newton's law, but apply here at this point. And I need to solve Newton's law applied to this point with the condition that the acceleration is 0, that there is no change on velocity of this point. So let's go to solve it. Okay? So I have T3 going down. T1 going in this direction through this angle alpha. And T2 going in this direction under this angle beta. So what I want to find, I know T3. T3 is mg. This is the value of T3. It's the weight that was acting on the body 1. I know what is this, but I want to find T1 and T2. I want to know if I pull with this force going down, how it will react here. This is the ceiling, okay? This is the rope, and this is the other rope, so we'll have tension here. I want to know how is the distribution of tensions in the rope. So I will apply Newton law. What is say Newton law? First things, I will go to my steps. First step, isolate the body. Isolate the body. In this case, the body is a point, sorry. Second step, make of the sum of the forces through the x-axis, put it m equal ax, and sum all the forces to the y-axis and put it m ay. Before that, choose a system of reference. Basically, these are the steps. So we'll choose this system of reference, the more natural system of reference. This is the x-axis, and this is the y-axis. Okay, y-axis. Okay? So let's go to write the equation on this system, to write this equation, and this equation, and to see what we can find. Let's go. Let's go to the next page. We have T1, T3. I hope you understood why T3 is going down, and I hope you understood why T3 is mg. It can be disturbing because you can think that the mg is applied on the body.
Would you say that T3 is combined with gravity because both of them going down?
Can you repeat?
Would you say that T3 is combined with gravity because both of them is going down?
If I say that?
T3 and gravity combined together?
No. What I mean exactly is that they are not combined, that they are completely two different forces. Let's go to see what is that. This is the object of mass m. mg is the force that the Earth is doing on the object. Is applied to the object. Is the force that the Earth is trying to attract the object going down. T3 is the force that the rope is doing up to sustain the object, to put the object at the same level and not making to move up or down. T3 is a force acting on the body. And from where is the origin of this force? The origin of this force is that there is a rope that is making a force on the body of mass m. Okay?
I can't hear you.
What?
Yeah, no, mute your mic.
Let me put the mute again. Let me put the mute again, participants. Okay, I put it the mute. Okay. Okay.
I'm sorry, Professor. I had a question.
Yes.
Earlier you had said that T3 was positive because it was what was holding it up or down. I'm confused.
Well,
Now you said it was negative.
T3 can be positive or negative, whatever you want to choose. If you choose this direction like positive, so T3 is positive and mg is negative. But if you choose this direction as positive, so mg is positive and T3 is negative.
Okay, so T3 would only be positive and negative when comparing them both together.
Right, right.
Okay.
So whatever you choose, you will obtain this equation, T3 minus mg equals 0. So I know that T3, the force that the rope is doing on the object, is exactly his weight, the force that the Earth is doing on the body. Well, it's a particular situation. But because I want to find T1 and T2, I need to apply to a small piece of the rope. This is the rope. Okay, this is the rope. So this is T3, that is the force that M is doing in the rope. Why T3 is like this? Because the force that the rope is doing on the mass is T3. You catch it? It's principle of action and reaction. So let's go to write the equation. The equation will be, this is my axis. I put my axis like this. X and Y. Okay? So I need to write the sum of all the forces in the X direction. Can you tell me what is the sum of all the forces in the X direction? Will be this force with an angle alpha, and will be this force with an angle beta. So will be T1 cosine of alpha minus T2 cosine of beta.
Hey, Professor, how are those the dotted lines? How are those on the X direction? They look like they're pointing down, so they're on the Y direction.
The Y direction is this one.
Yes, and you're saying that the forces that you just made with the dotted line are the forces in the
No.
X
I
direction.
made the dotted line is to make the projection. This is the T1 in the Y direction, and this is the T2 going in the Y direction. And this is T1X, if you want, T2X, and T2Y. So this is 21X, and this is 21Y.
Okay, got it, thank you.
So I'm making the sum of all the forces in the X direction. In this direction, I'm summing all the forces in the X direction. There is a component of the force in this direction that is T1X. But T1X is magnitude of T1 by cosine of alpha. So if you want, I can put it like this. If you like, I can put it like this. The sum of all the force in the X direction is T1X, the vector T1X, plus the vector T2X. But the vector T1X is the magnitude of T1 by the cosine of alpha. And the vector T2X is the vector that's going in the opposite direction. So it will be minus the magnitude of T2 by the cosine of beta. So this will be equal to the mass by the acceleration. But the acceleration, I said that the object is not accelerating in the X direction. It's not accelerating to the right. It's not accelerating to the left. It maintains his position. Then he's not accelerating. So the first equation that I have is this one. And I hope to find T1 and T2. This is my purpose, to find T1 and T2. T3 I already know, but T1 and T2 I don't know. So let's go to make again the set, or let's go to go down. Okay, so is this equation the sum of all the forces through the x-axis, T1 cosine of alpha, 30 degrees, I don't know, minus T2 cosine of beta, 60 degrees, I don't know, equals 0, is correct or not? There is more forces in the x direction. Do you see any other force going in the x direction? This is the ceiling. Oh, this is the ceiling. This is the rope. This is the other rope. Okay, this is the ceiling. Do you see another force going in the x direction? Do you see any other one in the x direction?
No.
No.
Me either. I don't see. I only see this force going in the x direction and this force going in the x direction, in the minus x direction, of
And they're
course.
equal to 0.
Sorry? Sorry?
And both forces are equal to 0.
The sum is 0 because the acceleration is 0. Okay? So, can you tell me through the y-axis how I will write the equation? So the sum of all the forces through the y-axis m by ay. Can you tell me the sum of all the forces through the y-axis? So I go to my picture and I see that T1 have a projection through the y-axis, that is this force, that is the same as this one. And T2 have a projection. So is T2 is this force. Are they in the same direction? Yes. So I have to sum. So how I have to sum? The quantity of the force that is in the y direction is T1 sine of alpha plus T2 sine of beta, because I have to sum because the both of them, they are projecting in the same direction. You see T2 is here and T1 is here. It's not like in the x direction that they are in opposite direction. They are in the same direction. And the value of T1, the value of T1y is T1 sine of alpha. And the value of T2 is T2 sine of beta. So the projections are here. So I have to sum this force with this other force. This force with this other force. This force is T1 sine of alpha. This other force is T2 sine of beta. So I have two equations, or three equations I have. So I have first equation, T3 equal mg. Second equation, T1 cosine of alpha minus T2 cosine of beta equals 0. And third equation, can you tell me the third equation? Tell me the third equation. The sum of all the forces through the y-axis. I have
0.
T1
Sine of the angle.
sine of alpha.
Minus T2 sine of.
Plus or minus?
Plus.
Oh yeah, plus.
Plus, because they are going in the same direction. The two components are going in the same direction. T2 sine of what? Beta.
Beta.
There is more forces in the y direction.
Yes, there's more forces in the y direction.
Which one?
Weight, T3.
T3. T3 is acting on the point minus T3. Minus T3. And this is 0. So the question you read like this, T1 sine of alpha plus T2 sine of beta minus mg equals 0. Because T3 is mg and T3 is going in the negative sign, in the negative, going down. So I have to put minus mg. Okay? So as a conclusion, I have two equations with two unknowns. What is the first equation? This one. I don't know T1 and I don't know T2, but I know alpha and I know beta. The second equation is this one. I don't know T1 and T2, but I know alpha, beta, and mg. I know mg. The mass of the body is 10 kilograms. G is 9.8. So I have a system of two equations with two unknowns. So let's go to solve it, okay? Let's
Professor?
go to... Yes?
The first one says T3 equals, was that mg?
Yes.
Okay, I couldn't understand. Never mind.
Wait, can you explain why in Fy, in the third equation, why it all equals to 0?
In the third equation, y is equal to 0, yes.
Yeah, why?
Because this should be equal to the mass by the acceleration in the y direction. So I go to the object. Oh, I'm the observer. Is this going accelerating up or down? This object. This point is accelerating up or down? It's not accelerating. It's in equilibrium. It's the problem said explicitly that the body is in equilibrium. So it's not accelerating in the positive direction of y, and it's also not accelerating going down in the negative direction. So if it's not accelerating, the acceleration AY is 0. So if the acceleration AY is 0 because dy is constant, because the chain of by is 0, because if by is constant, it's because the chain of by is 0. So the acceleration is 0, so I will put the sum of, I will put my equation that say the sum of all the forces on the y-axis, you put the mass by AY, but AY is 0, so m by 0 is 0. So I will put the 0 here. What is the second equation, sorry?
Okay, so AY and AX are both 0 when the system is in equilibrium, right? Okay.
If the object is in equilibrium, it's not accelerating. This is the, so AX and AY is 0 if the object is in equilibrium, okay? If the object is accelerating, it's because the object is not in equilibrium. And if the body is not in equilibrium, it's because there is a force, because the only way that he can accelerate it is because it has a net force. It's because the sum of all the forces is not 0. It's different than 0. If not, cannot accelerate it. Okay, so AY is Fy divided by M. This is. So if the sum is 0, the acceleration is 0. If the sum is positive, the acceleration is positive. If the sum is very, very big and the mass is very, very small, the acceleration is very, 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 very big. So the acceleration follows the force, the direction of the force. Okay, so let's go to solve this equation. Let's go to solve the problem now, okay? So the problem say, can you tell me what it say, the problem, the numbers? Can we find the numbers of the problems? Let me see. Well, I think that I did it here. So I did it here, so you can follow this. So the sum, I will do it here. The sum of all the forces is the mass by the acceleration. The sum of the forces in the y direction is the mass by the acceleration. If I put the equation for the x-axis, I will find T2 cosine of theta 2. T2 cosine of theta 2 is in this direction. So indeed, following the nomenclature that I have chosen, I should put it like this: minus to the left, this quantity to the left, and this quantity to the right as positive because I have chosen the x-axis like this. And this is the mass by the acceleration. So the equation that I have is this one, minus T2, yes, minus T2 sine of theta 2 plus T1 sine, no, sorry. This is for the x-axis, so it's minus T2 cosine of theta 2 plus T1 cosine of theta 1 equals 0. And for the y-axis, let me erase this, that I made a mistake. For the y-axis, I have some quantity of force in the y direction positive, that is T2 cosine of theta 2. So this is T2. And this direction is the y direction. And this is T2. This is, well, I call it theta 2, sorry, this is theta beta, theta 2. So will be T2 sine of theta 2, and the other T1 will have a projection here. This is theta 1, and we have a projection and will be plus T1 sine of theta 1. And this will be mass via the acceleration, but if it's in equilibrium, AX is equal 0, AY is equal 0. So the two equations that you will find will be like this. This equation we have already discussed. The first equation will be like this. The second equation will be like this. If you put this number alpha, beta, and m as I put it, T3 will be 10G, like 40 newtons. So the equation of the y-axis will be t1 sine of 10 plus t2 is sine of 30 minus 10g equals 0. So the t1 is here, the t2 is here, t1 sine of this angle is this one, plus the other one, t2 sine of theta 2 will be this force, minus what is going down, 10g, it will be 0. 0 because the object is in 0. This point is not accelerating. And for the x-axis, the equation is t1 cosine of 10 minus t2 cosine of 30. So if I work with the first equation, I will obtain t2 as a function of t1. I will put this t2 here, and I will obtain t1 sine of the t1, and I have obtained t1. Okay, you can make the numbers now and put it to plug sine of 10, cosine of 10, whatever you can plug it and find what is t1. Of course, t1 will be less than 40 newtons. Okay, so once that I find t1, I will take this number, I will put it here, and I will find t2, and the problem is solved. Okay? Okay?
You kind of lost me up on top. So
You
the
lost?
first part was just a little bit. So the first thing you did was you solved for t, and then you plugged it into the first part of the formula.
Sorry,
of the equation.
where are you lost? Here?
On the, yeah, right after that.
Here.
Yes, yes, correct.
Okay, if t1 cosine of 10 minus t2 cosine of 30 is 0, it's true that t1 cosine of 10 is equal to t2 cosine of 30? I put it on this one. It's true that t2 is simple t1 cosine of 10 divided by cosine of 30?
Yes.
Okay, so I take this value of t2 and I put it here where it says t2 on this equation. I will put it the value of t2 here. So the equation, this equation, the equation y through the y-axis will read like this: t1, sine of 10, sine of 10. t2, well, I will put t2. t2 is t1 cosine of 10 divided by cosine of 30. By sine of 30, minus 10g equals 0. So this is an equation that only the unknown is t1. You catch it? So I have shown a system of equations with two unknowns. So if I solve this equation, I will take t1 sine of 10, t1, this is t1 here, cosine of 10 sine of 30 divided by cosine of 30. This will be equal to 10g. The 10g will go up, I will go to the other side. So it will be positive 10g. So t1 will be 10g divided by this. So this is t1. Let's say that t1 is 20 newtons. Okay, once that I find t1 equal 20 newtons, I will go here, I will put 20, I will put cosine of 10, I will divide by cosine of 30, and I will find t2. Systems of equations. Okay.
So you're basically just plugging in numbers until you have only one unknown left to solve for.
Right,
Okay.
correct.
Okay, that was
the
better.
idea. The idea is when you plug in t2 as a function of t1, and you plug in here, the equation is translating only one unknown, the t1.
Professor?
Yes?
On the top where it says T3 equals 10G, why did you put 40 and something?
Well, because m is 10 by 10. Oh, m is 10 and the mass is 10 is 100, sorry.
Oh, okay.
Oh, sorry, it's like 100. Okay, it doesn't matter. Okay, 100, sorry. Sorry, very sorry. Huh? So this problem is solved. Let's go to see another example, okay? Another example.
And you said we can find these same exact paper notes that you're uploading.
Yeah,
Would
yes.
it be under the class recordings,
I
or
will,
can you put it as a separate
make
file?
it, clean it. I will make the same content that is here. I will make it, clean it, and easy to follow. So
Yeah,
do not
because-
worry about this, and I will solve the problem very, very quickly so you get the idea how it's being solved, and you can follow the idea, and immediately
on
you
our
will
own.
know how
Yeah,
to do it.
okay.
Maybe it's
Okay.
easier than to make the, well, I don't know if it's easier. If I tell you the truth, I don't know. I will see, but I will put the same contents tomorrow on Canvas. Do not worry about this. So what I said about this, let's go to do this problem, an elevator. Have you used an elevator? Have you ever used an elevator? Of course, you have used an elevator. So when you use the elevator, have you noticed that your weight is changing when you are arriving to your floor? Your weight is changing. It's a deceleration. The elevator have to decelerate in order to make velocity equal 0, so you can go out of the elevator. Meanwhile, the acceleration is changing. Well, if the acceleration is changing and is decreasing, so there is a force, and the sum of all the forces equal m by a. So if a is negative, the force will follow. So the idea of this problem is like this. Suppose that you have a weight machine, a weight scale that can measure your weight. How you measure your weight? So let's go to study this. You have your console to measure your weight. You stand up on the weight on the console, and you see your weight. But what exactly are you seeing? Are you seeing your weight? You think that you are, so this is the Earth. This is the Earth. The Earth is attracting you. How the console will measure your weight? So we apply Newton's. This is you. This is the Earth. The Earth is making a force going down, and the force is mg. This is the only force that is acting you when you are mounted, you are on the weight scale, or there is another force on you, acting on you?
Gravity?
Well, the gravity is here, it's the weight. The gravity make a force that is making you going down, but you don't go down. You are staying in the same place. Why?
Is there a force pushing you up?
Exactly, there is a force pushing up. Who make it the force? Who is making the force?
The scale?
The scale. The scale making a force. And we call this force the normal force. It's the force that pushing you up in a way that it compensates the force going down, and you don't fall, anything happen to you. So what you measure when you go to the weight scale is the magnitude of this force. And because the magnitude of this force is the magnitude of mg, you know what is your weight. So let's go to apply Newton's law when you stand up in a weight scale. So Newton's law will say this is you. There is a force mg going down, and there is a normal force going up, that is the force acting on you. We count only the forces acting on the body that we are studying. We isolate the body, and we will write n minus mg equal what? Mass by acceleration.
Zero.
Mass by acceleration. But what is the acceleration? It's zero. You are not falling up. You are not falling down. So the acceleration is zero. So the normal is mg. So the weight will measure the normal, mg. So now the problem here is a little bit more complicated in the way that now you are in an elevator. Let's go. You are in an elevator. This is you. And this is the scale of the elevator, okay? The floor is a scale elevator. So I want to know what is, if this is accelerating up, I want to know what is the normal n. So this is you. This is the weight going down, mg. There is the force that the weight scale is doing on you, the normal. And the sum, n minus mg, is equal to what? To mass by acceleration. And in this case, there is acceleration because you are in an elevator and you are moving with acceleration. So the normal, the weight that the weight scale will measure will be ma plus mg, or m plus g plus a. So means that you will have more weight when you are accelerating up. Means that the astronaut that needs to go out of the Earth, the acceleration is maybe 5g. So means that the force that are acting on them is maybe 6g. It's an incredible force. They can be squeezed by this force. So that's why the rocket cannot accelerate. Even if the technology allows you to accelerate to 10g, you cannot accelerate because you will die. So when you are in an elevator and you put a weight scale on the elevator, and the elevator is moving to accelerate you up, meaning that you are on the basement and you want to go to the 20th floor, and the elevator is accelerating, is changing the velocity from v equals 0 on the basement to b equal whatever it is, the velocity that it will achieve depending on the engines. So during this time, during the acceleration, the normal will be m by g plus a, will be bigger. You increase your weight. You increase your weight measuring by the weight scale. It's not that your weight has changed. Your weight is mg, but the measure of the scale will be bigger. So you will need a bigger strength in your legs to support the force that is acting on you. So let's go to do the problem again in different situation. So this is the elevator. This is you. And now you are accelerating down. So how I will apply, and of course there is a weight scale here that is measuring you. You think that the weight scale will measure more than before or less than before? The normal. So this is the guy. The guy have a constant force going down, that is mg. And now he has a normal n, that is the force that the weight scale is doing on him, and everything is moving with acceleration a. So I will write my equation and I will say, going down is mg. I will take going down all the positive directions because I will take the positive direction as the acceleration direction. So I will put mg plus mg. Look at the change that I have done. Now I put the weight in the positive direction. Minus n going up But going up means going in the opposite direction of the acceleration, equal m by a. So now the normal m will be mg minus ma. So the normal m will be m by g minus a. So you will find yourself very, very light, because now g minus a will be lower than 9.8, because you have to deduct the acceleration of the elevator. If the elevator is going with a equal g, the normal will be m by g minus g, because the acceleration value is g. So the normal will be 0. So you will not feel any force of the vascule on you. So you are in a free falling. You are falling like a free object with normal acceleration. So if you move in an elevator and the elevator is going to accelerate at 9.8, going down, you are moving at the same speed that the gravity is going down. So you feel that there is nothing acting on you. This is what is happening to the people, that the astronauts that are on the satellite station. You will see them that there is gravity. Of course there is gravity, but they are accelerating in the same direction. It's happening the same thing that this elevator is the Earth. He's accelerating in this direction like the elevator. So they feel that they are with no weight, because indeed they are falling. It's like falling at the same speed, at the same acceleration that the Earth is making you to fall. So you don't feel any acceleration, okay? So what happens if the elevator moves with constant velocity? So if the elevator moves with constant velocity, this A will be 0, and the normal will be mg. Is correct? Yes or no? Are you here? Or?
Yes, Professor, yes.
Yes or no?
Yes.
Yes.
Okay, but you are what time is it, by the way? 3:03. We talked that we are going to stop at 3:03 to make the quiz 3, no?
Yeah.
Yeah, you want to stop, or do I make one more example and we stop? Okay. We also talked that we were going to stop for 5 minutes at 2:40, no? Okay. This means that you are very interested on the class and you forgot everything. Maybe. Maybe. So let's go to do another example. Let's go to do this example. Okay, this example.
Professor, when are we going to do the examples from the quiz?
When we are going to do what?
The examples from the quiz.
From quiz 3?
The quiz, yeah, we took this Father's Day.
Yes, what I said is that I was going to stop at 3. Let me do one more example of Newton's law, and immediately we start to solve the question for quiz 3 that you were, okay?
Thank you.
Yes. So this problem, let's go to solve this problem to apply Newton's law. This is a famous problem. It's a pulley, M1 and M2. So if M2 is bigger than M1, what you expect is acceleration in this direction and acceleration in this direction. Is that correct? This is what you expect if M2 is bigger than M1. So let's go to apply Newton's law to these systems. And what we want to find is the tension and the acceleration. The acceleration depends on M1, on M2, and on G, the gravity. So we want to find the tension that are acting on everybody, and we want to find the tension T that is acting. So we follow these steps. First step, isolate the body. Which body will isolate first, M1 or M2?
M1.
It doesn't matter. M1 or M2, it doesn't matter. I will isolate both at the same time, M1 and M2. Okay? What is the force acting on M1? There is a force that is M1G going down. That is the force that the Earth is doing on the object. You have realized this idea? This is the Earth. I say that on M1, there is a force, M1G, that M1 by G, multiplied by G, that is the force that the Earth is doing on M1. You have realized that there is another force that is the force that M1 is doing on the Earth that is going up?
Mm-hmm.
Okay, there is a principle of action or reaction. So why the Earth do not accelerate in this direction? Because the mass of the Earth is so big that this force, F divided by the bigger mass, will make a small acceleration. F divided by the mass of the Earth will make a very, very small acceleration. So the massive object like the Earth will not feel acceleration, okay? Almost will not move, will not accelerate, because the mass, you can think of the mass as infinity mass. So the force divided by something infinity create an acceleration that is zero. So that's why the Earth does not move. It does not move respect to the mass M1, okay? So let's go to apply Newton's law to this problem. How do we apply? We've isolated the two bodies and we see what are the forces acting on the two bodies. What are the forces acting on M1? The weight. What is the other force acting on M1? What I see is a tension here, going down, up. And should be bigger, T1 should be bigger of M1G because I want to accelerate in this direction. Of course, T1, the equation that I will write is like this. T1 minus mg should be m1 by a. Okay, so I choose the direction positive of the acceleration. So I choose plus T1 minus mg in the negative direction equal m1 by a. So let's go to do the same thing for this object, for M2. So can you tell me for M2, what are the forces acting? So there is a force M2G. The object is moving in this direction with acceleration. So the only way that he's moving is that the tension T2 that is acting on here is smaller than M2G. Should be smaller, otherwise, if this force is bigger than this force, he will move up, but he's moving down, so M2G should be bigger than T2. So what is the equation that I will put? So my criteria is always the same. The acceleration is in this direction, I don't mind, I put it positive direction. And whatever doesn't go in this direction is negative. So I will put the second equation that I will write for M2 will be M2G minus T2 equal M2A. So again, I will put T1 equal T2 equal T, and again, I will have a system of two equations with two unknowns. What will be the two unknown? The two unknown will be the acceleration A and the tension T. So I have to find the solution to this problem. So let's go to find the solution of this problem. Equation one say T minus mg, m1g equal m1a. T minus, and equation 2 say that m2g minus t equal m2a. So I would write my object m1. I know t is going down. And I put not t1, I put t1 equal t. I will explain you why t1 is equal t on the next class maybe. But it's related that we consider that the rope have no mass. It's very interesting what I have to explain you why T1 is equal T2, but it's an idealistic situation when the rope has no mass. If the rope have mass, T1 is not equal to T2. So we are solving a problem like this one, like this one, like this one. It's a pulley. So this is the ceiling. We are solving a problem where the rope have no mass. Mass equals 0 of the rope. These are the two equations. So M1, the acceleration is going in this direction. So I'm choosing the acceleration like positive. Always I choose the acceleration like positive. So I will find M1 minus M1G, T minus M1G equal M1A. And for the mass M2, the acceleration is going down, M2G is going here, bigger, and T is going up. So I will write this equation. M2G, what is in the positive direction, this is the positive direction, minus T will be M2A. So I have a system of two equations with two unknowns, and the two unknowns are T and A. Yes?
Why do you put that M2G is positive when it's going down?
Good question. Good question. Very good question. And this is the idea. The object is accelerating in this direction. M2 is accelerating in this direction. Do you agree that it's accelerating in this direction? Why is accelerating in this direction? Because M1 is accelerating up. Mm-hmm. So if M1, and there is a pulley here, okay? So this one is accelerating in this direction, and this one is accelerating in this direction, okay? And the acceleration are the same one because they are connected with a rope, and the rope, we consider the rope not extensible. So the acceleration are the same. That's why I didn't put M1, A1, and A2. I should put A1 equal A2 equal A, T1 equal T2 equal T, and this is the equation that I'm solving. This is the equation. That's why I put at once, but I should have said that A1 and A2 are the same because they are connected with the same rope. So when M1 change the velocity in 3 meters per second, M2 will change the velocity in 3 meters per second in the same second because they are connected. No way that the acceleration will be different. So these are the two equations that I will find for applying Newton's law. So why I will put it M2G positive if you see it that is going in the negative direction? Because the acceleration is going down. So I will put always, I will follow the acceleration. I will say that if the acceleration is going down and I take it as positive, M2G will be positive. And what is not in this direction will be negative. The other way to do it is to change the sign of all the equations if you want. But I advise you not to do it. I advise you to follow this this idea. If A goes to the right, let's say, and you take it as positive, all forces or projection, all forces that goes to the right are positive. Now, if you, now again, I could say the same thing. If you take to the right negative, not positive, and you take the acceleration as negative in the positive direction, all the forces that you take to the right are negative. But I prefer to follow the acceleration as positive always, and you cannot be confused, okay? So the equation will say, what is in the positive direction? M2G. What is the positive direction? M2A is positive. If you want to put it negative, if you want to put this direction negative, the second equation will be, let's say that this is the negative direction. So we'll minus M2J plus T going up equal minus M2A, because A is going in the negative direction. But this equation and this equation is the same one. It's only to change the sign. So it's better not to change the sign and to take always the direction of the acceleration as positive. And all the forces that follow the acceleration are positive. If you follow this criteria, you will not fail. Okay? So again, I have two systems of equations. The first system of the equation is T minus N1G equal N1A. And the second is M2G minus T equal M2A. So I can sum, and the T will go M2 minus M1G equal M1 plus M2A. So the acceleration will be M2 minus M1 divided by M1 plus M2G. So if M1 is equal 10 kilograms and M2 is equal 100 kilograms, the acceleration will be M2, 100, minus M1, 10, divided by 110 by G, will be 90 divided by 110 by G, will be a fraction of G. 9 divided by 11 is a fraction of G. So the two objects will move up and down. One is going up and the other one is going down with acceleration that is not exactly G. Is the 1 and 2 that is going down is with acceleration lower than G. If I make N1 equals 0, if I make N1 equals 0 and N2 equal 100, the acceleration will be M2, 100, minus M1, 0, M1 minus M2, 100 by G. So will be G, because 100 minus 0 is 100, divided by 100 plus 0 is 100 by G, so will be 1G. So A2 will go down if the mass M1 will go like a free body and will falling down to the floor with the acceleration G if there is nothing, if there is not mass M1 acting on him. Okay? Is that clear? You got the idea what I did? Do we do another example?
Wait, can you go up to the part where you did M2 minus M1 and then times G equals M1 plus M2?
Here?
Yeah, there.
Here?
Yeah. You isolated T, and you equal it to
This
each
is
other.
the first equation for M1. This is the second equation for M2. Is correct?
Mm-hmm.
So if I sum the two equations, if I sum 1 plus 2, so will be T minus N1G plus M2G minus 2. This is the sum of 1 plus 2 equal M1 plus M2 by A. This is the sum here, is this sum. And the sum here is this sum. But T and minus T goes out. So will be, oh, it's my mom,
Hola.
sorry. Mamá,
Hola.
te tengo que dejar, mamá.
¿Qué hago?
Bien, mamá, te tengo que dejar. Te llamo en 10 minutos, en
Ah,
media
ya.
hora.
Es verdad que está en la clase.
Un beso.
Bueno, hasta luego.
Chao. So you met my mom. Good. So, what I did is here is I sum equation 1 with equation 2. When I sum equation 1 with equation 2, what I have is equation 1 is this one. So I put this here. I put this here, equation 1 plus equation 2. I put this here, M1 by A. And I put this here, M2 by A. So I sum this side with this side of the two equations. And when I sum, it will be M2 by G minus M1 by G because the T will cancel, T with minus T will cancel. And will be M1 plus M2 plus A. So the acceleration, that is what I'm looking for, the acceleration will be M2 minus M1 divided by M1 plus M2. So I found the acceleration. And if I know the acceleration, I will go to the first equation, to this equation. I will plug A here, and I will obtain T. Because T is N1 by A plus N1 by G. If I put A here, I will obtain the tension T. For this case, for example, you want to do it or you catch it?
I think I got it.
You got it? Okay.
Mm-hmm.
Okay, so choose one more example of quiz 3.
I have actually one more question though.
Yes.
About my previous question. So like when you're doing mass 1, because you said that the acceleration going up was positive, but then for the other one, the acceleration going down was positive. So it doesn't matter. Like, because you said basically that both directions were positive. So do you have to treat them as like separate, like free body diagrams? Like,
let's go to.
Because for me, I would have done like negative acceleration for a mass 2.
This is the body. This is the body of mass n. To where you want to make the body to move, up or down?
Just like how you had in the problem, like going up, right?
Let's say that it's
like
going
mass
up.
1.
So if it's going up, it's the acceleration going up. So you have to think. If he's moving up, it's because the force is going in this direction, the total force, correct?
Mm-hmm.
So on the body N, the total force is this one, but it's this one because there is a big force going up and a smaller force going down, and the total force is this one. Is the sum of this one plus this one that goes negative. So let's go to make this problem. So let's say F1, F2, and F, the total force, F. So the total force follows the acceleration. So the equation is that the force is mass by the acceleration, A. So if the force is positive at this size, because the mass is always positive, the acceleration should be follow the force. So if this is positive, if this is 10 Newton, what happened here? If this is 10 Newton, then we will the mass by the acceleration. The acceleration will be also positive. So this is the same direction. So if I want to call this direction the negative, doesn't matter. I will put minus 10 equal m, and I have to call the acceleration a also. So the acceleration will follow the direction. So the acceleration will be minus 10 also. So if you choose what I said, that you choose this force, the acceleration is going positive, you choose it. So you take F1 like positive and F2 negative, because it's going in the different direction of A. If you take this example, for example, and the acceleration is going down, it's because the force that is going down is bigger than the force that is going up. Otherwise, the acceleration cannot go down. So you take the acceleration as positive. So the equation that you will write for this object will be F1 will be positive and F2 will be negative. And this will be the mass by the acceleration, but the acceleration is positive. So the acceleration is positive and mass by acceleration is positive, and this is positive also, because it's F1 minus F2, and I take it F1 as positive. So the two sides, positive and positive, of the equation will be balanced.
Okay, so it doesn't matter the direction of the force 1 and force 2. What matters is like how big it is, like the magnitude.
No, what matters is the direction of the acceleration.
Okay.
Okay. It doesn't matter even the velocity v. The velocity can be go up or can be go down. It doesn't matter. What matters is the acceleration. So again,
so I guess my question is in the problem that you did with the rope, like if you establish that in mass 1 acceleration, if it's going up is positive, that you can say that acceleration in mass 2, if it's going down, is positive as well. Like you separate them, like they don't have to correlate.
You mean on the pulley?
Yeah.
Okay, I'm going to convince you. You see the pulley?
Mm-hmm.
Can you imagine the pulley, what I did? I took the pulley, I put it horizontal, the two body. I said, there is a force to the right that it has the value M1G, and there is a force to the left that have the value M2G. Is correct? Yeah. You see the abstraction that I have done? Okay. Mm-hmm. So this is the rope. Okay? So through these two bodies, what is the total force that is going? So you said, wait. To what it will accelerate this object? Let's say that it accelerates to this direction, because M2 is equal to M1. It's bigger than M1. So M2G is bigger than M1G. So what the equation that you will write? We will do it later going to the right. So I said that this acceleration is positive going in this direction. So I will put my force M2G positive, and I will put my other force M1G negative, going to the direction M1. And this is mass by acceleration. What mass I will put here? M1 or M2?
M2. M1 plus.
M1 but plus M2, because in the middle of this object, there is a force to the right, M1G. There is a force to the left, M2G. And in the middle, the mass that is M1 plus M2. So the acceleration is M2G minus M1G divided by M1 plus M2. If you see the solution to the problem that we did, this is the same result. And now
yeah,
let's
this
go
makes
to
more
do
sense
it.
to me.
Now let's go to do it choosing the acceleration positive to the right, okay? So you see that it will be the same one. So this is M1. This is the rope. This is M2. What are the forces acting on the system? What is my system? My system is not any longer the rope. My system is M1 and M2. So this is my system. And so what are the forces that are acting on M2? M2G to the right. What are the forces that are acting on M1? M1G. So I will choose the acceleration like this. I don't know if M1 and M2, like I put it before, M2G and M1G. So I don't know if M1 is bigger than M2. I don't know really. But let's say that I choose the acceleration like this. So if I choose the acceleration like this, it's because the mass M1G is bigger than M2G. So this is positive acceleration and this is positive acceleration. So I will write my equation. M1G, the force to the right, minus M2G, the force to the left, equal the mass by the acceleration. And I will obtain again the same equation. A equal M1 minus M2 divided by M1 plus M2 by G. So now you say, is this equation general? Of course that is general. Let's say that M1 is equal 10 kilogram and M2 is equal 100 kilogram. The acceleration will be 10 minus 100 divided by 110 by G. The acceleration will be minus 90 divided by 110 G. What does it mean that? That in this case that M1 is smaller than this one, the acceleration that I have chosen as positive in the right direction indeed is negative. It's going to the left. So the equation is completely general. So to avoid any complication, trust me, you choose an acceleration. If you don't know to where it will move, it doesn't matter. You say to the right is positive or to the left is positive. So every force that you find to the right is positive. Everything that you find in the left is negative. If you choose your acceleration to be to the left as negative, everything that you find to the left is negative. Everything that you find to the right is positive. Even if this is your common sense, will say that it's opposite. It's not opposite, it's the same thing. It's just a change on the side. So let's go to quiz 3 because it's 3:33. I will pause this class carefully, do not worry. And I will do many more examples. Many more examples, okay? Good. Quiz 3. What problem you want to do that you didn't know how to do it?
The parabolic one, please.
Parabolic one. And can you tell me what is the problem, please, that I don't know?
I don't have a picture or screenshot. If somebody does, they're more than welcome to say it.
If someone can tell me the numbers, the data, I can make it.
Is it the projectile motion, a pilot drops a package, or is it a rock is thrown from upper edge?
Was the rock the one that says where like it begins at 8 and it ends at 8?
No, I don't have a picture of that one. But
I can go.
You said the projectile motion one is the one you wanted?
Yeah.
Well, there were.
Listen, I can go to the quiz and see the problems. Let me.
Yeah, I think that's better. I think that's better.
Let me go just a moment. Let me go. Quiz 3. Quiz 3. Oh, just a moment.
Yeah, because there were 6 problems on that.
Yes, quiz 3. Let me see. Let me see. Edit. Questions. Question for quiz 3. Is the first one is one that say calculate the age, the height? I see the first one, like calculate the head. Is this one that you, let me see if I can share my screen.
Yes, that one, the height one. Yeah.
Say projection motion, as shown in the figure, a heavy rock is shot upward from the edge of a vertical cliff. It leaves the edge of the cliff with an initial velocity of 15 meters per second directed at 25 degrees from the vertical, and experience no appreciable air resistance at its travel. How high is the cliff? Is this one? Yes?
Yes, that was one of them, yeah.
So this is the problem. It's a very easy problem. This is the problem. You throw a projectile with an angle of 25 less 90 is what? Less 90 is 65, right? 65 degrees here with the horizontal, right? So the initial velocity V0 is the magnitude of the initial, is 15 meters per second. Okay? And the problem says that the parabolic movement will do like this, and this is 340 meters, right? This is the problem, correct?
Yes, sir.
You are watching my screen, sorry? You are,
I'm watching. Yeah, I'm watching.
Yes. Okay. So as I said in class, it's so easy problem to follow. This is Y0. This is what it's asking me. So what I said always in class, write the equation of movement. So the equation of movement said that X will be V0X by T, the velocity by the time. So V0X will be 15 cosine of 65 by T. So X of T will be 15 cosine of 65, which I don't know what is cosine of 65, whatever it is, this is the position at any time.
Why do we have to subtract 90 from 25?
90 minus 25 is how much?
It's 65, but what I'm asking is why did you have to subtract that?
Because the problem say here 25, I think that I read.
It says 25 degrees from the vertical.
From the vertical, it say this, so from the horizontal is 65.
Oh, okay.
Okay. The problem makes you to be confused with these stupid things that they never should ask you. They have to put it clear, the data, not to make you too confused. So y of t is y of 0, initial position, plus the chain. But the chain, when the movement is with constant velocity, is Vy by delta t. But this is not a movement in the y direction with constant velocity. And why? Because we have acceleration. So in the case that we have acceleration, I make a nice video to found this equation. Y0 is V0y by t minus 1/2 gt squared. So the y of t, the equation for y of t that you will obtain is y0, that you don't know, y0, plus v0y. v0y is 15 sine of 65 by t minus 1/2 phi t squared. So you have this equation and you have this equation. But you know that when it takes the floor, x of t, this distance, is 3.4. So 3.4 will be 15 cosine of 65 by t. So you know the time that it will takes to arrive to the floor. The time t that it takes to arrive to the floor is 3.4 divided by 15 cosine of 65. Oh, but this is the time to arrive to the floor. If I take this time and I plug in here, I will obtain y of t. But y of t is 0 because it has arrived to the floor. So I will obtain 0 equal y0, that is the one thing that I want to find, plus 15 sine of 65 plus t 3.4 divided by 15 cosine of 65 minus 5 t squared 3.4 divided by 15 cosine of 65 squared. So I have to extend y of 0. So minus y of 0 will be 15 by 3.4 tangent of 65, because it's sine divided by cosine, minus 5 by 3.4 squared divided by 15 squared, which is 225, cosine square of 65. So all this thing is a negative thing. And with this negative, y0 will be positive. If you don't believe me, we'll do it. We'll do it. You have a calculator there. Let's go to do it. Okay. Okay, y0, let me see that I did.
Professor, where did the 5t squared come from? The 5.
The 5, oh. I take g like 9.8, but I don't like 9.8. So 9 point, I take 10. 10 divided by 2 is 5.
Oh, okay.
So
okay.
I made a big mistake here because I know that the correct answer will be taking 9.8. And again, I don't understand why the text would want to use the calculator for nothing. So we'll take 9.8 divided by 2, which is 4.9, right? So we'll erase this and we'll put 4.9, right? So from here, we have to erase here and we have to calculate correctly. Correctly is both things, 4.9 only. So this is minus y0, right? Minus y0, this is from here, okay? So you make it and you find y0. Okay, so y0, let's go to do it. Y0 will be minus 15 by 3.4 tangent of 65 plus, because I'm changing the sign, 4.9 by 3.4 squared divided by 15 squared cosine square of 65. Well, it's already done, the problem. So difficult. It's not difficult at all. It's just to write the equation of movement. Once that you write the equation of movement and you know the interpretation, you know that this point t, this point x, 3.4, this x is when 3.4, there is a time t that elapses. So we take the time t to arrive here. So when we know this time t, 3 seconds, we know that at this time, the y was going up and up and up and up. When it's going here, y0 behaves 0. So I will put y of t equals 0. So 0 equal y0 and it's done the problem. Very easy problem. Okay. Any other problem? Yes?
What was the answer?
Oh, I don't know. You need to make if you want, we can find the answer. Y0 equal. Tell me tangent of 65. Tell me how much is this?
Tangent of 65 is 2.144.
2.144 by 3.4. How much?
We said divided by 3. No, multiplied would be 7.29.
By 15. Multiply by 15.
109.36.
Plus 3.4 squared. 3.4 squared.
Plus 3.4 squared would be 120.9.
3.4 squared will be like 10, 11.
Oh, I thought you said plus. Well, I just like already added it.
11.56.
11.66.
56.
Well, 56 plus 4.9 multiplied by 4.9. How much? By 5.
56.64.
Yeah.
56.54.
64.
Sorry?
64.
64. Oh, big difference from 54 to 64. Okay, 225 is 50 squared. Cosine of 65 squared. How much? How much? Cosine of 65. Well,
0.423.
Square? Already square, right?
No, not squared. It was just cosine of 65.
Yeah, square.
Should we square 65 first?
Cosine of 65 is 0.4. 0.4 by 0.4, 0.43 by 0.43, how much it is?
0.178.
0.178. Multiplied by 225, these things, how much it will be?
40.18.
40.18. 18. And 56.64 divided by 40.18, how much it will be?
$1.409. 409.
1.409. There is something that we did wrong. Can I do it again, the equations? Maybe something is wrong. Let me see. X of t is V0x. Let me do it without numbers. And we find the V0x by t. So V0 cosine of theta by t. So X is 3.43, 3 point what? 3.4. 3.4. When X is 3.4, this implies that 3.4 is equal V0 cosine of theta by t. Theta is the angle with the horizontal. So t is 3.4 divided by V0 by cosine of theta. So the question for y of t is y0 plus V0 yt minus 1/2 gt squared. So when t equal 3.4 divided by V0 cosine of theta, whatever is this time, y of t is 0. So I will put this equation 0 equal y0 plus V0y, V0 cosine of 35. So V0 sine of, sine of theta. Let me erase here. Okay, V0y is V0 sine of theta. Remember that theta is this angle, okay? The angle with the x or V0 by t minus 1/2 gt squared. So let's go to put it the t on his place. T is this value, 3.4. T is this value, 3.4 divided by V0. So y0 minus y0 is V0 sine of theta by t, that is 3.4 divided by V0 cosine of theta, minus 1/2 gt squared. T squared is 3.4 divided by V0 cosine of theta, everything squared. So y0 minus y0, sorry, minus y0 is, maybe it's correct because it was minus y0. So you know why I did it? So it's minus y0 here, no? It's minus y0. So it's correct. You know what I was doing again? Because I saw that y0 was going to be negative. So if we didn't make any mistake, y0 is 107 meters. Okay? But it's better always not to introduce any numbers. It's better always to work with the most general way, and at the end you plug in the number. So let's go to do it, and we plug it the numbers again. So V0 is going out with V0. Sine of theta is cosine of theta is tangent of theta with 3.4. So in this way I have reduced to make many calculations. Minus 1/2 g t squared 3.4 squared divided by V0 squared cosine square of theta. So y0 is equal 1/2 g 3.4 squared divided by V0 squared cosine square of theta minus 3.4 times tangent of theta. And now I will put the number, I will plug the number now. So y0 will be 1/2, 9.8, 3.4 squared, I don't know what is that, 15 squared, cosine square of 65 was, no, 25, 65, 3.4 squared minus 3.4 tangent of 65. Now it's done. Do this calculation and you will find the y0. Should be the same one that I did before if I did not make any mistake. So 107 meters, maybe 106 meters, around this height, around this result. And what is the result that they ask you? Let me see. Let me see. Let me see if I can see. I can see the question. Okay. Yes. I don't see. Is possible answer say 68 meters? This is what it say?
Yeah.
Okay. So calculate this. Calculate everything like this. And this should be 68 meters. You want to calculate to be confident on me? Okay, let's go to calculate. But calculate correctly, because the way that we calculate before, I didn't like. I know that this was some mistake we did. 9.48 divided by 4 is 4.9. 4.9 by 3.4 squared. Can you tell me it was? How much?
11.56.
56. So cosine of 65? Cosine of 65, can anyone tell me?
I got 0.423.
0.423.
423.
And
But
square?
is it squared though? Oh,
Yes, I have to put it square. So
squared is 0.179.
by 225?
I got 40.186.
40.1.
86.
Okay, and now 1156 for 4.9.
56.644.
56.44.
So you get
644.
644. 64.
when you do the
divided by
calculations.
40.1.
1.4. 1.413.
Sorry, there is.
When you do the calculation, you get like negative 5.88 around there.
Where I made the mistake, sorry?
Well, that was actually the answer I got. I got 5.88.
I got that answer too.
For the
I
height.
got that answer too.
It marked it wrong.
What answer did you get?
5.88.
5.88 on the exam, and I got it wrong.
You mean that the possible answer here is wrong?
I mean, yeah, it
The
suggested,
one that they put on the quiz.
yeah, it suggested 68, the answer, but I don't think that's the answer for it.
Well,
Because if the length is 3.4, I don't think the height would be 68 meters.
Yes.
I mean, but we didn't finish the bottom.
Yes,
We didn't even
maybe.
finish
And the result that is giving us here is not this one. It's let me see. What is the result here?
Professor,
this is the equation. If you take a time to solve this equation and you plug the number, this is the correct answer. Y0 equal, change all the sign. This is, okay? This is Y0, for sure is correct. I didn't make any mistake. So
exactly.
So if you take,
and when we finish,
if you take your time to make these calculations, you will find the height, and the height is not 60 meters for what I see.
Yeah, the answer on the quiz is wrong.
Maybe it's yes, maybe it's, but it's easy to calculate the height.
Yeah, it's not how you're calculating it. It's just the answer on the quiz is wrong.
Yeah, I know. But it's answer, no, I mean, what is answer to figure out what is Y0. It's not difficult to find out what is V0, what is Y0. And Y0 is the height, Y0 is the height that will have T 3.4, let me see. Well, it's not, for sure, it's not 60 meters, for sure.
Professor, can I explain to you how I solved the problem?
Yes, of course.
Okay, so what I used was the range equation, which is range equals Vx times time.
It's here. The range equation is here. It's somewhere on here. Use it. Yes, but you can use it directly, and you found with the range equation, you can find the time t. So it's the same thing that I did. And with the time t, you find the height.
So when I got the time, it was 0.27 seconds.
20?
0.27.
0.27. So this should be this time. 3.4.27 seconds. This should be
correct.
The answer for time was 0.536.
I don't know where you.
Is it 0.5?
36, yeah.
Well, this time is correct.
Why are you? It never gives you an angle.
This time is correct. I think that you have this time because you are not doing the angle with the vertical, as the problem say.
It didn't give us an angle.
It say 25 degree directly from the vertical, from the vertical. It say the angles is 25 degrees from the vertical. So you use the equation with theta equal 25. You need to use the equation that you are using with theta equal 65. Because this is the angle with the horizontal, and the equation that you are using for the range, it appears theta as the angle with the horizontal axis. Okay? So if you use with the horizontal axis, you will find that the time t is this one. Okay?
Professor, what did you get as the answer?
What?
What was your answer that you got?
It's here. It's only that I need a calculator, and I don't have any calculator. This
It'd be
one, what is tangent of 65? Let me know what is tangent of 65.
2.1445.
2.1?
445.
Listen, do not worry. I will solve it and I will post this question. Tell me which other question you want me to post. Question one?
Professor, I just want to make a comment. So we noticed how like the quiz answer could have been wrong. So this just kind of makes me worried that if you're not making the test yourself and you said that they were produced by Canvas or whatever, it makes me wonder if there's going to be more issues like this for the test.
Repeat again that what?
Okay, so what I'm saying is that if we have seen that there's an issue with this quiz, that the answer was supposed to be, or the quiz answer was 68, but that's not the answer, it makes me worried for the test, because if the test is the same format, I don't want to run into the same issues for the test.
Oh,
you understand?
well, I will check all the solution then. I will check that the solution are correct for every of the problem. If there is any problem with the question that it has the wrong solution, I will cancel the problem from the test, from the quiz. Okay.
I'm talking about the test, not the quiz.
The test, do not worry. The test, it will not be the same thing. It will not be like this. I don't like this kind of test.
Okay, yeah, me neither. That's why I was worried, Professor.
I don't like. I think they are tests to make confuse people, not to check the knowledge of nothing. It's just to make them to be confused.
I agree.
So I prefer to create my own test, and test one, you will find my own test. It will be a simple test. It will check your knowledge in simple things, how to apply Newton's in very simple situations. So you know you can do it. You don't know, you cannot do it.
It'll be translated before it gets to you guys, so don't worry about that part. We'll make sure that it's like legible for you guys, just like past quizzes, not this past one, but like the ones beforehand, kind of like that.
Do not worry. It will be well prepared. So can you tell me any other question that you feel that there is the question that is a wrong answer?
Professor, there was one question where the answer was 54 and I put 54.0.
Yes.
And it gave it to me wrong.
Well, but the answer is 54. It's right. Yeah. Maybe it's a point that you don't put.
We can't hear you, Professor.
Yes, that I said that maybe, you know, if you don't make the space between the 54 meters per second and you write 54 with the space, and maybe it give you the wrong answer, but the solution is correct. I don't know. But what I want to know is, there is, from this kind of problem, there are some problems that you didn't know how to do it?
Yeah, Professor, there was one that I didn't know how to do.
Which one?
I'll read you the problem. It says, shown below are the velocity and acceleration vectors for an object in several different types of motion. In which case is the object slowing down and turning to its right? And all it gave is the options of like the vectors pointing in different directions.
Yes. Can you tell me which number of question is this one?
Well, the questions are
This
different.
one. This one. I found it. Okay. This is maybe the most interesting question. Projectile motion. Show the velocity and acceleration vector of an object in several different types of motion. In what the case is the object slowing down?
And turning to its right.
Okay. So let's go to it. Do you see my screen? Do you see my screen?
Yes.
Yes. Okay, let's go to do this problem. This is the most important problem that you have to do. And it's the kind of question that I have insist that you have to visualize. And it's the thing that you have to make sure that you know, because applying Newton's to see this, it will discover many things. So this is the velocity v. Okay, and this is the acceleration a. Can I sum with a? Can I sum b with a?
No, because they're different vectors.
Exactly. Can I sum b with a by delta t?
Yes, because that is the same thing as velocity.
Delta v, this is delta v. So v plus delta v. So this is the vector v. This is the acceleration a. In the time delta t, let me see the picture as they draw exactly v. I try to put it, I think it's almost perpendicular. I think a is perpendicular, a is like this. So a by delta t will be this quantity, correct? This is a, this is v, according to the picture, and this is v by delta t. So v by a by delta t is this one. So v final will be v initial, this is the initial velocity, plus the change. And the change is this one. So this is the change, a by delta t. So v final will be like this. But the acceleration goes perpendicular to the movement, to the direction of the velocity. You see that the acceleration is perpendicular. So if you consider this delta t very, very small, what it will do, this acceleration, instantaneously speaking, what it will do, it will change the v to a new v. Let's go to put a circle. The v, it will change the v. Let's go to put a circle. Let me draw again. So if the okay, now this is v. Let's go to see. This is v.
Professor, I thought only the acceleration was perpendicular to the vector in uniform circular motion.
Right. If this v, this acceleration, I don't see clearly if it goes like this, maybe the acceleration. If it go like this, a, it will change the a by delta t. A will be like this, and a by delta t will be like this. So it will change the magnitude. So v final will be v initial plus the change a by delta t. So v initial is this one. The acceleration, I cannot see how it has the picture. It looks like perpendicular, but maybe it's not perpendicular. It's like this. A is like.
What are you looking at, though, Professor? Because there's just all there is 4 or 5 options to choose from. There's not a set.
They choose. In what case is the object slowing down and turning to? Oh, sorry. I was trying to see in every case
Yeah, that's what.
Velocity is increasing or not increasing.
Yeah, that's what I thought you were doing. But all it is just gives you options and choose.
So very easy. So it's very easy. So in the first case, I don't see clear, but in the second case, you see that the acceleration in the second case have a component parallel to B.
Yes.
The second case is like this, V and A, like this, A. So A by delta T will have a component in this direction. So we'll make a change in the magnitude of the velocity. And A by delta T will have a component in the perpendicular direction. So we have to analyze the two directions, parallel to B and perpendicular to B. So this is the way to analyze. So second, we are going to make the second one. V is going to accelerate. It's not the one. He wants me to find when it's not going to accelerate. When it's not going to accelerate is this one. V, look at V. A is going to like this. So I will put A in two components, parallel to B, A parallel, and perpendicular to A, to B.
Wait, Professor, how is that parallel to V? It's on the same line?
This is V. This is V, okay?
Yeah.
This is A. As I said, I cannot sum with B with A, but I can sum B with A delta T. Okay, this is A by delta T. You see A? You see A by delta T?
Yes.
Okay, this is the vector velocity. This one. Okay.
Yes.
This is the line perpendicular to V. This
Yes.
is the line parallel to V.
Okay, what I'm saying is that isn't a parallel line not supposed to touch or intersect with the other line?
Is the parallel line this one not to what?
Like it's not supposed to touch that same vector. It's just supposed to be running alongside of it.
No, it goes in the same direction that the vector V.
Okay.
It's going exactly parallel to B, exactly parallel to B. So what happened? A by delta T is A by delta T have one component like this, A parallel by delta T, and it has another component, A perpendicular by delta T. This component of the acceleration is making the velocity to decelerate because V final equal V initial, this one, plus the chain, this one, A parallel by delta T. And this component, this one, A perpendicular by delta T, is making the velocity to rotate like this. So it will happen two things. The velocity will be lower and rotates. This is the effect of the acceleration. So if you have the body, for example, like this, you have the body like this, you can see here, this is a parabolic movement. The acceleration is going like this. So the velocity is going, B is going like this. It's moving A by delta T. It's moving all the time going lower. So the acceleration is changing. But in this case that we have the acceleration in this direction, the acceleration is making the velocity V to be reduced because it's acceleration braking. It's like a brake in your car. You are in your car with this velocity, and now you have this acceleration, and this acceleration is making you two things. First thing is making you to decrease your velocity because there are a term that is opposed to the velocity, that is A parallel by delta T. And the other thing that is making the other component of the acceleration is making your car to turn in a curve. I'm making the velocity like this. So at the end, you start like this, and the acceleration will make you to go in this way with shorter velocity, with different magnitude. So this is the acceleration that makes you to go to decrease your velocity, okay? The other picture makes your velocity to increase. This is the only one that makes you to decrease the velocity. So it's like this. If you have this velocity and you have this acceleration, A, where your velocity will be B final, will be B initial, plus A by delta T. So A by delta T will be this vector. So I will add it to A by delta T, and B will grow up B. But if your initial velocity is this one, V, same one, V, but A by delta T is going like this, V initial, so your final velocity, V final, will be V initial plus A by delta T. But A by delta T will be opposed. So V final will be V initial minus A by delta T, because A is going in this direction. So the final velocity will be V final. This V initial, A by delta T, V final. So after some times, what will happen? V final will be like this. A by delta T will be like this. And the B final final, B final final, B final final will be B final plus A by delta T will be B final final, will be the B final minus A by delta T, because it's going in this direction. So V will be 0. And if you go again with more, you will have a vector with V velocity V, and A by delta T will act. So V final will be V initial minus A by delta T, and the new vector will be like this, V final. So you have to see how the vector A by delta T is acting on the body. For example, if you have a projectile movement, this is V initial. After some time, VA by delta T or G by delta T, the acceleration is going up. So the V final will be this one, because V final is equal V initial plus G by delta T. So you start with this one and you leave the G act again. So G by delta T will be another G by delta T. So this is another V final. So B final final will be B final, this one, plus another G by delta T. So at the end, the vector velocity is moving like this. And if you leave it, G delta T, the acceleration, the delta V, the change in the velocity is acceleration. By delta T, the velocity V will be like this, and the movement will be like this. So if you catch this figure in a vector form, G vector, if you catch this figure, you can see how the vector V is changing all the time. So the acceleration makes change in the vector velocity. So let's say that V is here, and the acceleration is like this, A. So I cannot sum B with A, but after some times I can sum V with A by delta T. But how I will sum A by delta T? I will project this A by delta T parallel to B. And I project this A by delta T perpendicular. So I will say that I have V plus this vector, A parallel by delta T, plus this vector, A perpendicular by delta t, that is this one. So what happened that the V initial is changing in magnitude and is changing in direction. So this is the V final. To see this is very important, A parallel by delta t. To see this is very important because when you see this, you see the movement, how it's changing the vector velocity by the action of accelerations. So in this case, this acceleration A is making the velocity to change in magnitude. This magnitude is changing, and it's making the velocity to change in direction. This angle theta has changed. This angle theta has changed. So this is V final. So the equation that you have, that's why I insist so much that you have to see this equation, is V initial plus the chain. And the chain is A by delta t, A vector A by delta t. Normally you see this equation only in one dimension. So in one dimension it's like this, V initial, A by delta t in this direction. So V final is V0 plus A by delta t. So this is V final. So you see that the object is accelerating, is changing the velocity, is increasing the velocity. But in one dimension, you lose the richness of the things because you don't see the change, the rotation of the vector. So to see the rotation of the vector is very important because the movement happens in the universe in 3 dimensions, not in 1 dimension, okay?
Wow, Professor, I'm gonna be honest, that was extremely complicated just to solve a problem like that.
No, this problem, this problem, you need to know this, you need to practice this kind of things.
Yeah, I didn't really get that.
For example, let's go to see the part 3. The acceleration is, you see the picture, this picture that I have in my screen now. Now let me share the screen. Let me share the screen. Let me see how I can share the screen here. Okay. You see my screen now?
Yes.
Okay, for example, this one, this second part, you see that there is a acceleration that is projected through the velocity, so the velocity will be increasing. You see that the acceleration, A by delta t, have a projection on the, let me see if I can write, and let me
Right,
see.
and like
You see
that
that
one.
the acceleration will be this one. This is the acceleration. This is the acceleration. You see that this acceleration will have a component on the direction parallel to V and will make V to grow up in this direction.
Yeah.
And you see that it will make to rotate also because it has another component like this, the acceleration. So the acceleration A is this vector plus this vector. So this vector, the second one, makes the velocity to change in magnitude. And this vector, the second one of the acceleration, it makes the velocity to change in direction. It will be like this, in this direction. But it will be in this direction and increase the velocity. The vector final will be like this. So this condition makes the velocity to rotate and to accelerate, to increase the velocity. But the problem is slowing down. So slowing down means that the velocity will decrease. So this question makes the acceleration to go in this direction, so it will brake. When you have a car and you are moving with this velocity, your brake make an acceleration in this direction in order to velocity change from this amount to a lower amount, until you stop. Until you stop, you don't leave the pedal. you leave the pedal on the brake until you stop, right? So the acceleration A is this in this direction. So in this case, the acceleration is changing the velocity, going down the velocity, and also the acceleration have a component in this direction. So it's making also the velocity to change in this direction. So the velocity is changing and go smaller. The velocity will be like this. Initially it's like this. Let's go to put it bigger. Finally it's like this. It's going smaller. Finally it's like this. It's going smaller. Finally it's like this. It's going smaller and rotating. And at the end, it will go in the direction of the acceleration, A. This will happen if you go, for example, in your car and and the acceleration that is acting on your car is this one. You will lower your velocity, and at the end, you will appear in this direction, in the direction of the acceleration. You are turning to be parallel the final velocity with the acceleration. This is what will happen. So imagine like this, if you want, you can see in this picture, you can see like this. Let me put it like this. Let me put it like this. Let me see, how can I, let me see. You can put it like this. So imagine like this. Imagine you are here. Imagine you have this velocity. And imagine the acceleration is going in this direction. So this acceleration will make you to change the velocity, delta V, in this parallel direction. And it will make the velocity to change in this direction, delta V perpendicular. So V final will be A, V final will be the vector A by delta T. So V final will be V initial, this vector, plus A by delta T. So is this what is happening all the time, okay? If you take a small times delta T, it will be like this, maybe. It will be V final like this, V final like this, V final like this, and at the end, it will be like this, okay? If you keep doing, at the end, V final will be parallel to A by delta T. So it's like a force that is pushing you to make you to follow the acceleration. So you follow the vector velocity will follow at the end the acceleration if you wait enough time. Okay? But instantaneously speaking, you only make a small change in the vector velocity. After you wait, you make another small change in the vector velocity. So you make many change. It's like for example, this is the vector velocity, no?
You know.
Yes.
Yeah, I wanted to ask, like, so the acceleration can only kind of like decrease or increase, but it cannot change. The only thing that can change is just the velocity, right?
The acceleration can change both things. Can change the magnitude of the vector velocity, and the acceleration can change the direction of the vector velocity.
The acceleration cannot change itself, right?
The acceleration cannot change by itself, you mean?
Yes, it can only increase and decrease, right? Like,
well, if the acceleration is a constant acceleration, means that the acceleration Is constant means that have the same value and the same direction. So you don't change the acceleration, but you can find something that the acceleration is not constant, that can change the magnitude, and maybe the acceleration can change in direction, but this will be more complicated problems. So you don't study this kind of problem. The problem that you study is you have a vector velocity, v0. You put an acceleration, let's say this one, an acceleration a. So you imagine that a small time delta t, what is the change? Because the acceleration is the change in velocity per unit of time. You know that the change in velocity is a by delta t. So you imagine a small delta t, a touch, like you are starting to hit the object. So you're starting to hit the body, the object with a delta t very small. So a by delta t will be this process, a by delta t. So you will find b final. After some times, if a is maintained constant in direction, a by delta t will be this one. So b final will be this one. After some time very long, a by very big delta t will be this vector. So the b final will be this one. And if you make it a time delta t very long, the b final will be parallel to a. So the action of this acceleration, bit by bit, has been in changing the magnitude of the velocity and in changing the direction. So the velocity v final here has changed because now it's much more bigger than the other one and have another direction. Look at this, it's much more bigger than this one, and the direction has changed. So the effect of the acceleration has been in producing and changing the vector velocity in magnitude and in directions. Easy to understand or not easy? I have made some videos explaining these things, but I think that I was not lucky to explain this thing because you have not catch it, no? Or you have catch this idea? Did you see this video? I think that I made videos like this and I put, for example, the velocity v going like this and the acceleration going like this. So I said, well, there must be a chain of v in this direction and there must be a chain of v going in the perpendicular direction. So v final, if delta t is equal 1, so if delta t is equal 1, so a by delta t is the change in the velocity. Because I choose delta p equal 1 microseconds, 10 a la minus 6 seconds, let's say. So b final will be like this. After another 1 microseconds, a by delta t will act, so b final will be like this. After another 1 microsecond, b final will be like this. So after a long time, b final will be parallel to a. V and A will be parallel. And this is happening when you pull something. When you pull something, let's say that you pull something. Let's say that this object is moving like this and you pull it in this direction with this force, meaning with this acceleration, because this force must by acceleration. So the object will go like this, and at the end, will be parallel to the force, will be parallel to the acceleration, the movement. If you wait a little bit, but at the beginning, the impact of the force or the acceleration, when you are talking about force, you are talking also about acceleration. The impact will be to change the magnitude of the velocity and to change the direction of the velocity. Both things happen. But if the acceleration is in the same direction as the velocity, will only change the magnitude. will not change the direction. Okay? Okay, so I'll see you on Thursday. What do I have to do? Do I have to review the third quiz to check that all the answers are correct, or you know which one are not correct?
For me, I wasn't able to take it because I think I told you my situation, and you told me to talk to you after class.
Benji, I will open for you. I will open for you.
Yeah, because you opened it before, and then when I clicked.
Just a moment, Benji. Sí, Raymond, dime. Ah, sí. Ah, te agradezco. Se lo puedes agarrar y ya bajo a recogerlo. Gracias. Benji, you want to make the exam again, the quiz?
Yes.
Let me see how I can do it. Let me see.
Okay.
Let me see how I can do it. Quiz 3. It is supposed to be open, and you said that you cannot take it.
Yeah, because like every time I go to it, it just show me the exact like.
Okay, quiz 3. Okay, let me see. Benji, right? Benji. Oh, let me put here Eugen. No result. You are not here or what? How is possible that you are not here? Let me find you. Eugen. Not. Benji, you are in my class.
You say what?
It looks, let me see. Eugen, what is your email, Benji?
B-E-U-G-E.
B?
Yeah, B-E-U.
E-U.
B-E-U.
Yes. Let me find you. Let me find you just a moment.
Is class over, Professor?
Almost over.
Because there's only 7 people left.
Yes. Whatever you need to talk to me, you can talk to me now.
No, it's fine. I'm just gonna go.
Okay. So good luck. I'll see you on Thursday.
All right.
All right. Thank you.
Okay. Bye. Please, Benji, stay with me until I can get you to take the quiz.
Okay. Thank you.
Let me see what I can do. Let me see. First, let me see people here. People. Let me see if I can see you because I didn't see you here. Benji, said people. Eugen, right?
Yes, Eugene.
Benji, Eugen, you are here, Benji, Eugen. So this is your login, Benji, Eugen. Okay. So now I will go to quiz 3. So I will go here and I will assign you. Let me see if I can change here time limits. Benji. So if I put here Benji, you have seen my screen? No. You are not watching my screen, right?
No, I'm not. I cannot see what you're doing.
Let me share my screen so you can see and let me know what happened here.
Okay.
Are you watching my screen now?
Yes.
So if I put here Benji, I don't know why. Ben.
B-N D-J-I.
D-J-I.
I think you put it's I. J-I.
Yeah, but there's no result here. Let me change this maybe. Maybe if I do it like this.
DJI.
Well, I cannot assign to you. Let me, if I can repeat it. Let me see, Benji. Let me see how can I do it. Let me see. You want to take pictures of the quiz?
I mean, yeah.
Take the picture of this quiz if you can. Take the picture.
I can see it. I can see it. Like I can open it, but when I open it, I see what because I had opened it already, and then it submit by itself. I didn't get a chance to take it. So once I put my
so Benji, make the quiz and send me by email, and I will review myself. Okay.
Okay. So let me just take. So I will just do it in paper and then send it to you.
Yes, yes. I think it will be better.
Okay.
Okay. So Benji, good luck.
Thank you. Yep.
Okay. Okay. Bye-bye.
Bye. Yeah. Shall we? Okay.
¿La que no? ¿La del norte? No sé, pero no quiero ir a ustedes. Toca dibujar la del norte. Chao. ¿Te espero o no te espero? ¿Ah? Coño, Gaby. Gaby. Ok, ¿te espero o no te espero? Eso es lo que estoy preguntando. Dale. ¿Qué?